Welcome back to the History of Mathematics. This is our fourth video concerning some material from Chapter 2 of Stuart Hollingdale's book, Makers of Mathematics. This concerns classical Greek mathematics. Now, one of the focal points of the chapter is the Pythagoreans, and that name is pretty famous, well known. Most people will recognize it because of the Pythagorean Theorem. So I thought it might be a nice idea to go over a proof of the Pythagorean Theorem. So every student of mathematics should understand at least one proof for this theorem. It's very important here. So we're going to prove the Pythagorean Theorem with the aid of this figure. So what I've done is I have arranged four identical right triangles so that they form a large square. And what I'm going to do is I'm going to find the area of this figure in two ways. Okay, so first way, we're going to treat this as a large square, which it is. Now, of course, to find the area of a square, let's just call that area A. So the area A would be equal to, well, length times width. So that'd be A plus B, the total length of the base there, times A plus B. And if we do a little algebra, we distribute and combine like terms, we'd have A squared plus 2AB plus B squared. So that's one way to look at the area of this figure. Of course, there is another way to look at the area of this figure. We could look at that figure as four triangles, and a smaller square. Okay, right up here, we can see what I'm talking about right there. 1, 2, 3, 4 triangles around the perimeter and this smaller tilted square. Now, of course, we know how to find the area of a triangle, 1/2 the base times the height. So the area of an individual triangle would be 1/2 AB. Now, the total area of all four triangles can be found by just multiplying this quantity by 4. Since the four triangles are identical, they would all have the same area. And then we need to add in the area of that tilted square. So the area of our figure A would be given by this expression here. Of course, we could simplify right here. That's 2AB plus C squared. So this expression gives the area of my figure, and this expression also gives the area of my figure. So those two expressions must be equal to each other. So thus we have A squared plus 2AB plus B squared would have to be equal to 2AB plus C squared, or A squared plus B squared equals C squared, the famous Pythagorean theorem. So this figure right here can be used to establish the Pythagorean theorem right down here. And the technique was to find two different expressions for the area of my figure and set those expressions equal to each other.